One of the reasons Kubernetes feels hard is because for the simple task, you involve multiple resources. Let's take an example of RBAC. You create service account, role binding, sometimes cluster role bindings, and for so many people, it feels like the collection of YAML files that they remember without actually really understanding it. So in this video, let's understand it instead of memorizing how the Kubernetes react when some request comes in. Because once you understand that flow, RBAC becomes surprisingly simple. Let's start with a very common scenario. Imagine we have a backend application running inside a pod. Maybe it's an operator, it's an automation job, or internal platform service. At some point, application wants to interact with Kubernetes itself. For example, pods, services, secrets. The application sends a request to Kubernetes API, and at that moment, Kubernetes has to make a decision. Should this request be allowed? Before Kubernetes can answer that question, it needs to answer another question: who is sending the request? And that's where RBAC journey begins. Because every access decision in Kubernetes starts with identity, not permissions. Identity. When people start to learn about RBAC, they think the service account is all about the permissions. They are not. A service account answers exactly one question: who is making this request? Let's say we create a service account called backend API and we assign it to our pod. Now, whatever that pod talks to Kubernetes, it's speaking as backend API. You can think of a service account as the identity attached to a workload, not what it can do, just who it is. And this distinction is really important because by now Kubernetes knows who is making that request, but it still doesn't know whether the request should be allowed. Knowing the name automatically doesn't mean that we need to grant the access. And that's the next step. Now let's say our backend application that we created needs to access the pod information, nothing else. It doesn't need the deployments, it doesn't need the stateful sets, secrets, or anything else. Just pod information. So this is where the role comes in. A role defines a set of permissions. What actions are allowed on which resources. For example, in resource pods, there are 3 actions included: read, list, and watch. But that's all. You cannot create the pods, delete the pods, or modify the pods. One thing that I like about RBAC in Kubernetes is it's explicit. When you look at a role, you can immediately understand what the workload is supposed to do. But still we are missing one piece. We have identity and we have permissions. But still they are different, they are not connected. This is usually the moment where RBAC clicks people because role itself doesn't grant access. Identity itself doesn't grant access. They only become useful when they are connected. That's the job of role binding. A role binding simply says give this permission to this identity. That's it. So now our flow looks like this. There is a pod, there is a service account, there is a role binding, and that connects to the role. Let's follow a real request. The application asks, can I read the pod information? Kubernetes checks who is making the request, the service account. What permissions are attached to the service account? The role binding tells Kubernetes which role to use. The role contains the allowed actions. If reading pods is listed there, request approves. If it doesn't, request is denied. Once you understand this flow, the troubleshooting of RBAC becomes a lot easier because you know where to check for the role. You know where to check for the bindings. Usually, most RBAC related issues are one of these 3 things. Everything we have discussed so far works only within one namespace. But in a cluster, there are not only one namespace, there are maybe hundreds. Also think about the monitoring system, Prometheus, Datadog, Grafana agents, cluster operators. This component often requires the visibility inside entire cluster, not just one namespace. Creating the same role repeatedly in dozens of namespaces quickly becomes difficult to manage. That's why Kubernetes provides the ClusterRoles. Conceptually, a cluster role is not a new idea. It's the same idea as a role. The difference is scope. The role is namespace scoped and a cluster role can be used across the entire cluster. And naturally, cluster role binding performs the same action, same function as role binding, but a cluster level. So the mental mode doesn't change, only the scope changes. Kubernetes often introduces a cluster-wide operation of some namespace-wide operations. RBAC is one of the example for that. If there is one thing that I want you to remember from this video is not YAML, but the flow I told you just now. Whenever Kubernetes receives a request, think about these questions. Who is making the request? What permissions do they have? And does that permission allow this action? And the RBAC resource directly mapped this into the question. Service account is all about the identity. Roles or the cluster roles, it's about the permissions. Role binding and cluster role binding, it's about the assignment. Once you understand this flow, it's in your head, you don't consider RBAC as 5 different resources in Kubernetes. It feels like one authorization unit. So that's all for this video. I hope you have understood about the RBAC, the role bindings, the service accounts, the roles, the cluster roles, and everything. If so, then I expect a like and comment from you guys. And if you want to understand much about the Kubernetes and want me to cover the multiple other topics, then please leave the comment. And yes, thank you for watching till the end. We'll see us in the next video.